Hello dear students. So our next topic is quantization of electric charge. The definition is the property by virtue of which all the free charges are integral multiple of a basic unit of charge. What is the basic unit of charge here? It is E. And the value of E is 1.6 into 10 raised to power minus 19 coulombs. And N here is integer whose values is plus minus 1, plus minus 2 and so on, and Q is the total charge here. Since N is an integer, it can't have value in between the main values like in points or in fractions. So next question is a charge of this much of Coulomb possible? So total charge is given to you. You know the basic value of E. So by applying the quantization formula, what is N here? Q by E. So N is equal to 5.8 into 10 ki power minus 18 divided by 1.6 into 10 raised to power minus 19, which is equal to 36.25, which can't be possible. Either it should have a value of 36 or 37. So this kind of a charge doesn't exist. So next is Coulomb's law, and it is very important law in this chapter, first chapter. It states that the force of interaction between any two point charges, suppose these two are point charges and the distance between them is r, then the force is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. Let us say this is the first equation, this is the second equation. On combining these two equations, we getting this force is proportional to Q1 Q2 by R square. And when we are going to remove this proportionality sign, we will introduce a constant K here, which is known as electrostatic force constant, and having a numerical value 9 into 10 ki power 9 Newton meter square per coulomb, and epsilon naught here is 8.85 into 10 ki power minus 12. This epsilon naught means absolute electrical permittivity of free space. Basically, permittivity is a measure of how an electric field affects and is affected by a medium. If we are going to change the medium, this epsilon goes to some epsilon value. Naught stands for the free space. This is the basic notation for naught. So we are doing calculations on the basis of permittivity. So on the basis of the above formula, we are going to do this question. How is the force between two charges affected when charge is doubled and distance between them is halved? So for this question, as we all know, the formula is F equals to K Q1 Q2 by R square. Here charges is doubled, that means the new Q1 dash is twice now as it is doubled. New Q dash 2 is also twice, and new R dash becomes half as it is halved. Now substituting these values in the new formula for new force, K remains constant, Q1 dash is 2Q1, Q2 dash is 2Q2 divided by R by 2 whole square. It becomes F dash is equals to K is a constant, 2 to the 4, Q1, Q2, divided by r square by 4, which again comes in the numerator. So nu f dash will be equals to 16k q1 q2 by r square, and this is the again formula f. So we can write as nu f dash is equals to 16 times of old force. So how much force changes? It's 16 times. So second question is, I have changed here half now and distance between them is doubled. Now you have to do this question and upload your answers. This is your homework question. This is the end of today's session. In the next session, we are going to start with the continuous charge distribution. Till then, revise the topics which we have covered. Thank you.